We look at this quadratic, x squared plus 6x minus 1, and I say solve the quadratic. First thing you should be thinking when you see an equation is like, can I get x by itself? No. The next thing you should be thinking is like, oh, can I turn this into x plus something times x plus something? And then you're like, no, you can't. There are no two numbers that multiply to get -1 and add to get 6. Again, I will show you a technique to solve a quadratic. We are not going to use this technique, okay? But it's going to kind of segue us into the technique we will use to solve this quadratic. Got it? Okay. What I'm going to do is just get the 1 over to the right side. Now, we usually don't like to do this. We usually like things set equal to 0. But I have a plan, okay? My plan is going to involve the fact that I know that x plus 3 squared, hopefully you didn't make this mistake on your lesson, on your quiz today, is x squared plus 6x plus 9. Not x squared plus 9, right? You guys know that? Like x plus 3 squared is x squared plus 6x plus 9. And I notice I have x squared plus 6x. Well, I'm going to decide, because I'm just going to, try something here. I'm just going to add 9 to both sides. And what I get is x squared plus 6x plus 9 equals 10. And you still might be thinking, but Mr. Messner, we don't like quadratics equal to numbers. It doesn't help us. But actually, it will. Not if we factor the left side so it looks like this. Again, that doesn't really help us. But if we take this left side and turn it into this, this is like a question I asked you on day 1. And you can solve this. Solve this. Write something down, see what you get, see if it's the way that you think I'm going to want it. It's like, just try to figure it out. If you have your homeworks out, please put them underneath your notes and just embrace this lesson and what I'm going to teach you. It might give you a different perspective on things, which might help you in the long run. Well, I see x. I can get x by itself. Guy, what do you think we can do to get x by itself? What do you want to do first? Jolly, what do you want to do first? How do you get x by itself? Like, I got to get rid of that and that. What do you want to do first? Good. Square root both sides. If you haven't figured that out, everybody, square root both sides. Cool? Shaw, Dylan. Is it Dylan? Dylan. What do you're Dylan. Elliot. What do you have to remember when you use a square root to solve an equation? Oh, you got to put plus or minus. Okay, so a lot of us, I know, did not put plus or minus root 10. We should look to simplify root 10. But can root 10 turn into the product of a perfect square times a non-perfect square? No. Like the square root of 5 is just the square root of 5. The square root of 2 is just the square root of 2. We're looking for numbers like 4 or 9 or 16 or 25. So those don't go into 10. So this is completely simplified the square root of 10. The last thing I would do is I would subtract 3. And I would probably put it as -3. Like adding -3 is the same as subtracting 3. -3 plus or minus root 10. These are my solutions. I just got it. I just obtained these solutions using this technique called completing the square. I completed the square. We're not completing the square in this class. It takes too long. And actually, there's another technique that uses completing the square that mathematicians figured out a very long time ago. Mathematicians discovered that for any quadratic equation like this, you could do the same procedure, no matter what numbers you have. It could be any a x squared plus any b times x plus any c. They could do the same type of thing that we did, and they would be able to get the answers by using this technique. So what they decided to do is use ax squared, bx, and c, and try to solve that equation by completing the square. So flip to the other side, you'll see something crazy. Smart mathematicians were like, yo, let's solve any equation a x squared plus b times x plus c equals 0 by completing the square. And this is what they did. They started by dividing everything by a. Boom, a goes away. We have b over a, we have c over a. Then, just like we moved the 1 over, they're going to move the c over a over by subtracting it. Following me so far? So now I have, probably should have showed this middle step, x squared plus b over ax equals negative c over a. Cool? So that's like us moving the 1 over. Then, what did we do? We added 9 to both sides. Why did we add 9? Because we knew like x plus 3 squared was x squared plus 6x plus 9. Okay? They need to figure out what can be added to both sides so that we kind of complete the square. And they discovered that, well, you take this middle number, we had 6. You take that 6 divided by 2, got 3. Square that, you got 9. Okay? Middle number divided by 2 squared. So they took the middle number, b over a, divided by 2. Now, it doesn't look like it's divided by 2, but b over a divided by 2 is the same as 1/2 times b over a. Okay, so b over a divided by 2 squared. They added that to both sides. Cool? And they said, well, over here on this right side, let's like focus on making the right side look a little bit nicer. Okay, and they said, okay, well, let's square b over 2a. And when you square b over 2a, you get b squared. That's b squared, and then 2a squared. 2a squared, 2a times 2a, 4a squared. Cool? Is everybody kind of following? And then they're like, well, this right side could look a little bit nicer. So let's kind of combine these two by getting a common denominator. I'm going to multiply this by 4a over 4a. It gives me b squared over 4a squared, and it gives me 4ac over 4a squared. Cool. Now you can combine these two fractions. It gets b squared minus 4ac over the common denominator, 4a squared. And now they have the right side looking nice and simplified. And they're like, okay, this is good. We're going to leave the right side alone. Let's go back to the left side where we've completed the square, and we realize that what we have is x plus b over a divided by 2 squared. This is that whole x plus 3 squared. Cool. And now what did we do next? We square rooted both sides. Okay, they square rooted both sides. But when you square root a fraction, you can square root the top. You can square root the bottom. When you square root the bottom, you realize that the square root of 4a squared just turns into 2a. You can't square root the top and simplify it because of the subtraction. It makes square rooting tough to simplify. So I get this. We don't forget our plus or minus, do we, Elliot? We don't. We always remember our plus or minus when we use a square root. And then we finish things off by subtracting b over 2a. And we get this. Very few teachers teach this formula, it's called the quadratic formula, as, yo, this is just mathematicians completing the square for every single quadratic. The quadratic formula comes from completing the square. I don't like teaching completing the square because if you use the quadratic formula, you're using completing the square. So we're just going to use the quadratic formula and not worry about completing the square. Are you guys cool with that? Great. Now, you might be used to going one extra step further and writing the quadratic formula like this. You guys all know the quadratic formula jingle. No? Your Algebra 1 teachers didn't teach you the quadratic formula jingle? Did anybody have to sing the quadratic formula song in Algebra 1? What are we doing? Okay? What are we even doing here? When I taught Algebra 1, they had to sing it. You had to sing like this. Ready? Here it goes, Archer. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Yo, you don't have that memorized? You got to memorize it in this class because we're not giving it to you. And if you need to ask for the jingle again, I'll sing it because I have no shame. Okay? Great. This is how you learn it. This is what I like. This is Mr. Messner's preferred quadratic formula. And I'll show you why. And hopefully you'll learn something. First of all, you're learning that the quadratic formula is really just completing the square. That's something that you might not have learned, or you've forgotten if your teacher told you. The other thing you're going to learn is the hidden information received inside the quadratic formula. I am going to take this example to show you what I'm talking about. Okay. Let's say we want to find the zeros of x squared minus 10x plus 21. Let's pretend we tried to factor, but we couldn't figure it out. The quadratic formula is what I call like our backup. This is always our backup. If we can't figure out how to factor, or there's going to be somewhere we just can't factor, we can use the quadratic formula. Here's what you do. You identify A. All right, A is 1. It is the number that is not seen but there, the coefficient of x squared, not always 1. The number that's there. B is 10. C is 21. You will be using the quadratic formula without a calculator. So get ready. X equals the opposite of B over 2A is what I like to do first. So I do the opposite of B. Sorry, B was negative 10. So the opposite of B is positive 10 over 2A. 2 times 1 is 2. So I get X equals 5. That's the first part. Then I have plus or minus the square root of B squared minus 4AC. Now, you're doing this without a calculator, so you might as well do some of the math like up front instead of writing down all the steps, or else you might make a mistake. I'm going to do B squared, like in my head. Negative 10 squared, that's 100. So I'm going to put down 100 once my cursor comes back. It's coming. Don't worry. There it is. 100 minus 4 times A times C. Now, instead of writing 4 times 1 times 21, maybe I'm just going to do like, oh, well, I just need to do 21 times 4. I'm going to do that on the side. Okay, that's 84. And I'm going to put 84 inside that square root once my cursor comes back. There, 84. And that is divided by 2A. And then I could do a little bit of work, maybe on the side, maybe in between. 100 minus 84, got to figure that out. Well, this is going to be a 9. That's going to be a 6. This is going to be 16. So we got the square root of 16 over 2. I'm just going to kind of do a little bit of work on the side. And that's going to be 4 over 2. And that's just going to be 2. Okay? Now, here's the beautiful thing about the quadratic formula that a lot of teachers miss out on teaching you. Look at these clouds here. This is great. Maybe we'll get some rain. No, sorry, look at the board. Look. I graphed this quadratic equation earlier. What is the beautiful thing you notice about the quadratic equation? Tell your neighbors, what are some things you notice about the graph of a quadratic? What are some things you notice about the graph of the quadratic? Say some things you notice about the graph of the quadratic. I like that, McCorkle. Yo, it's a U shape and it's symmetrical. Symmetry is important in quadratic. Now let's take a look at what you notice. 5, 5. Well, looking at the graph of this quadratic, what do you see? That smack dab in the middle was 5. This has to be the case. If you have two solutions and there's symmetry, the solutions must be equal distance to a one point. Well, the point they must be like equal distance to has to be the middle if there's symmetry. What you just realized is that within the quadratic formula, you can see the middle of your graph, which means this 2 represents the distance it takes to get to your solution. If you add 2 to 5, oh, I get 7. Hooray! If I subtract 2 from 5, I get 3. Hooray! 5 is smack dab in between the two solutions. Boom! All seen in the quadratic formula. And this is why I prefer this method, this split up quadratic formula. Because if you're asked to find the vertex, you don't have to think of this being a completely different problem. You could be like, oh, the quadratic formula has the vertex finder within the formula. A middle plus or minus a distance gives us our solution. All we have to do to find the vertex, which is the middle of the graph, is do the first part, the opposite of b, over 2 times a. Boom. This is like a little sidebar that the quadratic formula, yes, gives you your solutions, but it also gives you your vertex. Now, let's pretend I did not know the quadratic formula existed. Don't erase it. But let's pretend you did not know the quadratic formula existed, or let's say you were asked to find the zeros of this first and you factored it, and you said, oh, that's x minus 7, x minus 3, easy. The solutions are 3 and 7, easy. Could you potentially, using your knowledge of the zeros, find the vertex of your equation? Tell your neighbors, if you knew the zeros, could you find the vertex? What would you do? How can you take 7 and 3 and turn them into 5? Now, a lot of you are saying subtract them, but if I subtract 3 from 7, I get 4. How can I turn 4 into 5? Yeah, whoa, that's crazy. No, you're not thinking about the right way. How do we find the middle of two numbers? Average. How do you find the average of something? Add them up, then divide. So all you subtract. What you want to do is add them, divide by 2. This finds the average or the midpoint. So, guys, again, this is a little bit of a sidebar, this vertex conversation, because we really ultimately are talking about finding the zeros, but you will be asked about finding locations of the vertex. Let's say you have this equation. Turns out this equation is the same as this, but it looks different. If you found the solutions were 3 and 1, you can just look at them and know in between 3 and 1 is 2. But the way we find that is finding the average. Add and then divide by the amount of things we're talking about here. So boom, we find the vertex. That's easy. There's two ways to find the vertex, either using the quadratic formula or you average your zeros. Both of these use the concept of symmetry to help them, okay? But let's go back to the important things, and actually there's multiple things you're being asked for. You want the x-coordinate of the vertex, but then you want the x-intercepts, roots, and zeros. Now, first thing you know, x-intercepts, roots, and zeros are all the same thing. We're just going to be trying to solve this equation set equal to 0. Now, always my first choice is to solve by direct solving. My second choice, if I can't direct solve, is to factor. If I can't direct solve, if I can't factor, now we use our backup. Yo, it's raining. Look at us. We've made it. Oh my gosh. This is incredible. We did it. Has it been? Oh man, I'm just so caught up. I hope it's raining at my house right now because I really need the rain. All right. If you can't factor, if you can't direct solve, boom. Yo, your quadratic formula is here to help us. He's your backup. He's your check. He's your, I can't figure it out. What do I do? You can use the quadratic formula. Go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you are looking back on the previous page because you forgot the quadratic formula, I'm going to tell your Algebra 1 teacher. And she's going to be mad. Or he. X equals negative b over 2x plus or minus the square root of b squared minus 4ac all over 2a. That's Mr. Mester's way. X equals negative b over 2x plus or minus the square root of b squared minus 4ac all over 2a. Opposite of b over 2a. 1/4 plus or minus square root b squared minus 4ac over 2a. You got to figure out what the square root is, then you got to divide it by 4 after. Don't divide the stuff inside the square root by 4. Do some of this work, guys, in your head. A is 2, B is -1, C is -2. Make sure you have identified what A and B and C is. I get B squared, which is 1, minus 4 times 2 times -2. On the side, I'm going to do 4 times 2 times -2. And I'm going to make sure I don't make any mistakes. Don't be afraid of doing a little bit of work on the side, guys. I feel like people mess up on the quadratic formula when they try to fit everything in the formula. Do the work on the side and then fit some stuff in the formula. And then I get 1/4 plus or minus the square root of 17 over 4. If I could simplify the square root of 17, I would. I can't, so I don't. So, boom. These are my zeros. These are my zeros. These are my roots. These are my x-intercepts. 1/4 plus root 17 over 4. 1/4 minus root 17 over 4. Where's my vertex? What's the x-coordinate of your vertex? Tell your neighbors. Where's the x-coordinate of your vertex? Did you pay attention? The x-coordinate of the vertex is at 1/4. The quadratic formula helps you. Okay, let's do this one. Go. Using the quadratic formula, solve the equation. what you are essentially doing are completing the square. It's just like the smart mathematicians completed the square for you, created this formula. My recommendation, do some of the work on the outside of the formula. Try to keep the formula as nice as possible. You don't have to fit everything into the formula. I get 1 plus or minus root 8 over 2. Anybody else get 1 plus or minus root 8 over 2? Did anybody get something else besides that? Hopefully. Because you might be feeling good about yourself, and if this is tough doing arithmetic by, using the quadratic formula without a calculator, get used to it tonight. But you feel good about yourself, you look on your multiple choice answer choices, you don't see that, okay? You don't see that. Doesn't mean you did something wrong, it just means you might have to simplify. Don't forget how to simplify. Square roots. Root 8 is root 4, root 2. Root 4 is 2, root 2. This actually can be 1 plus or minus 2 root 2 over 2, which actually, after dividing the top and bottom by 2, is 1 plus or minus root 2. You would be responsible for getting that if this was a multiple choice question. Got it? Okay. These are very much the same. If anything, I'm going to ask you to pay attention to this one. Finding the vertex, you do not have to use the quadratic formula. You can use your zeros. You know where the zeros are. Average them together. Don't subtract, you add, divide by 2. X equals -1/2 would be the x-coordinate vertex. This is another quadratic formula. We don't have time, we have to move on. Okay. We get to this equation, we have another quadratic. Tell your neighbors, if I plug in -3 and square and then add 9, do I get a solution? Is x equals -3 the solution to x squared plus 9 equals 0? Tell your neighbors, is that the solution? Is that the solution? No. It's got to be, right? Because oh no, you're right. -3 squared plus 9, that's 9 plus, that's 18. Yeah, 18 is not 0. That's all right. That's all right. Okay, well, that was a good guess, but I obviously was wrong. So let me try something again. Let me try to actually solve this instead of just guessing. So let me try to get x by itself. Go ahead. What would you do to get x by itself? What was your first step that you would do? Good, subtract 9. What would be the second thing to do to get x by itself? Oh, we take the square root. Now we need a plus or minus when we use the square root. Thank you, Elliot. Let me get that. Well, oh, okay, must be positive and -3. Is that right? No. We already know -3 doesn't work. +3 is not going to work. We get to this situation. The square root of -9, okay? This is not a number that I know, because I know that -3 squared is +9. So I don't know of a number that multiplied by itself gives us a negative value. I don't know of a number multiplied by itself to get a negative number. Negative times a negative is a positive times a positive is a positive. But if I took this and plugged it in here, it would solve the equation, right? If I took the square root of -9 and squared it and then added 9, yeah, okay, well, the square root and the square are going to go away. And it's like, boom, that works. So we introduced something that theoretically doesn't make sense to us. I don't know of a square root of a negative. However, it solves the equation. This is kind of confusing to us. It's complex, right? So let's just call it a complex solution. Something that doesn't really make sense to us, but it works. It's more theoretical than anything. Now, complex numbers, complex solutions show up often in mathematics. Shows up so often that we're going to use special notation and call them special types of numbers. The square root of a negative, we are going to call imaginary. We're going to call it an I. And if we said the solution was plus or minus root -9, actually, to like help us not have square roots all over the place, mathematicians decided, yo, you can simplify this to be the square root of the number and the square root of the negative. And we will get 3i. This is a number that doesn't really exist, but it solves the equation. The square root of -9 squared plus 9 does equal 0. Cool. You're in charge of finding these solutions. These solutions can be found directly by solving. Subtract 16, square root both sides, making sure you have a plus or minus, making sure you know that you'll have the square root of the number and the square root of the negative. The square root of the number, sometimes we'll be able to do, sometimes we'll just have to simplify. The square root of negatives we'll call I. That is just signifying that we have this imaginary, this complex idea, this complex solution. You did the other one, you subtract 75, you divide by 3, you get x squared equals -25. You get x equals plus or minus 5i. Cool? We could direct solve this. Let's do this one on the right. What would be the first thing you would do? Tell your neighbors. Do the one on the right. Subtract 8. What would be the next thing you would do? Tell your neighbors. Good. We get x minus 3 equals. We got a plus or minus. Don't forget that. We got to figure out what to do with root -8. Well, here's what I'm going to do. I got root 8 and root -1. That takes care of the negative. The root of -1 is I. I simplify the square root of 8. If I cannot make it like a whole number, well, it's root 4, root 2. So that's 2 root 2. We've done that enough. Hopefully, we're all comfortable with simplifying root 8 to be 2 root 2. Okay? Well, I still have x minus 3. So the last thing to do would be to add 3. The one key thing is that you're not allowed to add numbers to imaginaries. It's like try to add 3 to the square root of -9. Well, I don't even know what the square root of -9 is to begin with. So like, don't try to add it. Instead, just like keep it separate. And boom, those are your complex solutions. The final thing you'll see is that you will get complex solutions if you're solving quadratics and you use the quadratic formula. Opposite of BA over 2 times A plus or minus the square root of B squared, that's 16 minus 4 times A times 13, that's 62. You'll get -16. No, -36. I don't even know. We'll figure it out. You're going to get the square root of some negative number in here. and then you'll be able to solve for this, okay? Hey, bring your chairs over if you brought chairs over. This whole backpack thing is great. Thanks, Will. All right, finishing off, let's actually figure out what this is. B squared minus 4ac. What's 52 minus 16? Yeah, it's 36. You get negative 36 in here. So I get negative 2 plus or minus. Okay. Square root of 36, square root of negative 1. This is going to be 6i over 2. You can take 6 and divide it by 2, giving me my solutions. Negative 2 plus or minus 3i. Same thing happens over here on the right, left side. Hello? Yes. Yes. Cool. Yep. I appreciate it. You guys come whenever. You have our permission, and we won't bother you. No, you're staying in the front of the property, so we won't have to worry about dogs or anything. You guys are fine. Thank you very much. I appreciate it. You too, bye. Get my trees trimmed because they're bothering the power line. Sorry. Solving these equations, you know, like really we do want to start always like this. You could complete the square. This is something easy enough where you could just add 1 to both sides and like boom, that's x plus 1 times x plus 1. But let's say you're not comfortable with completing a square, or it's not something as obvious as 2x. It could be like a 3x. X equals the opposite of b over 2a plus or minus square root b squared 4 times 1 times 5 over 2a, negative 1 plus or minus, this is the square root of negative 16, which is 4i over 2, 2i. We did it. Mr. Messers, out.